Hi, welcome to PR Tech Talk. Dialog is a company that have an interesting product. It is an ultra-low power Wi-Fi module for battery-powered IoT devices. This module is the DA16200 MOD and are fully certified by FCC, IC, CE and others. The DA16200 MOD consists of the DA16200 SoC, 4 MB of flash, crystal oscillator, needed RF components, and onboard chip antenna or external antenna connector if that is better suited for your product. It's a small size, 14 by 22 mm. You can run the module on its own, but in this video we are going to use the Renesas RA2L1 to drive the module using the UART connection and AT commands. The whole TCP/IP stack will run on the module, making it easy to attach any MCU to it. To interface the module to Renesas EVK RA2L1 board, I designed a small PCB matching the microbus pin headers. Soldered on the module some passives and some pin headers on the PCB. I used the free online software EasyEDA to make the schematics and the PCB. First I needed to create the DA16200 mod component, since it wasn't available when I made the design. When the component was made, I continued with the schematics. Then imported the netlist into the PCB tool and finalized the board. When I was done with the design, I ordered it using the JLCPCB, and it took approximately 2 weeks to get them delivered to my home. To solder SMD components, I do recommend to use proper tools. I have a small home office lab that was sufficient for this task. You need initial to program the module with the firmware matching your needs. Dialog have an EVK for the DA16200 that can be useful. You get both UART connection available with one USB connector to your PC. I used this evaluation board for the initial testing, but it gets a bit messy with a lot of wires eventually. If you can't find a suitable firmware, you can compile your own. I used the standard firmware that I downloaded from Dialog's web page, using their multi-downloader tool. You can also use the Terra-term script to do this, and Dialog are providing the script also. After connecting the module to my Renesas board and making the project setup, I didn't get anything out from the module. My initial thoughts were that I killed the module with my hot air, or perhaps I got a bad connection on some solder joints. But after ruling out these errors, I found the issue. I mixed up the TX and RX. But back to the lab and I made some fixes, and now it works just fine. Now I have the module connecting to my home network access point, getting the DHCP lease and then connecting to my local mosquito broker running on the Raspberry Pi 4. I then get some temperature readings from the MCP9808 over the I2C and send it using the MQTT to my Home Assistant, running also from same Raspberry Pi 4. I also attached an RGB OLED using the SPI interface. I will create some smaller videos with more details creating this project. It needs to be divided into parts to be easier and more digestible. I hope you find this project interesting and looking forward to see the coming videos on it. Please make comments, like and subscribe. If you want to follow along, please take a look at my other videos on the channel. And to get your free eSquare Studio installed, see the video on installing the FSP 3.0.0. Stay safe and I hope to see you in the coming videos. Bye!